Welcome! In this presentation, we will explore the effects of behavioral changes on the functional organization of the brain. For an overview, I will explain some key terms of the functional organization of the human brain, and then we will look at an experiment and its findings. The functional organization of the brain relates to the structure of a brain that has divided functional areas, like subcircuits that are responsible for certain functions. For example, if we move, the circuits responsible get active and many processes happen. Overall, the functional organization of the human brain is remarkably stable. It doesn't change from one day to another or when we change our behavior. However, there are instances where we can observe changes. Plasticity determined by active usage is critical for shaping neural circuits during development, learning, and even during recovery from an injury. Spontaneous brain activity is part of brain plasticity and it's very important. It helps with the development of neural circuits. Spontaneous activity is also present during sleep when it transfers newly formed memory from the hippocampus to the cortex. And it's also very important during brain development in utero when it helps to shape the brain circuits of the baby. When the brain processes a specific task, we can observe spontaneous activity of multiple synchronized related brain regions. This is the functional connectivity, and it's represented by correlations that we see when multiple activities occur together in the brain during one event. Over the years, when the same brain regions activate together multiple times, they make the functional connectivity stronger. And we will now look at an experiment by Newbold et al. That recorded the brain activities that happened short time during a behavioral change. Newbold et al. Researched the effects of behavioral changes on brain organization during short time period. They created a drastic behavioral change of their 3 participants to induce brain plasticity by casting the dominant arm for 2 weeks, in their case the right arms. They tested their brain activity every day for 30 minutes using fMRIs, and they could observe the effects of behavioral changes on brain organization of the participants during these 2 weeks. They found that disused brain regions disconnected rapidly from the motor system and manifested large spontaneous activity pulses inside of its own subcircuit responsible for upper right arm movement. Now we will look at different results measured for one of the participants. Here we have the measurements of daily movement and strength from before, during, and after wearing the cast. Wrist movement decreased significantly during the period of the 2 weeks of wearing the cast, and as well that happened with the strength. It decreased until 1 day after cast removal. They both returned back to normal after the cast was removed. And here we can see the brain activity that was recorded during fMRI scans. Before the cast, we can see how the activity in the right upper arm, illustrated by the blue dot, this region is connected with other brain regions and with the opposite brain hemisphere. And this is called the homotopic connectivity. During the cast, this homotopic connectivity was disconnected. The recordings during scan showed that the left primary somatosensor cortex, which represents the disused upper arm of the participants, is no longer connected to the other brain part. So the homotopic functional connectivity doesn't exist anymore. But interestingly, there is a lot more activity inside of the subcircuit itself, so more functional activity is present here. The same thing we can see also in this illustration, the somatomotor system before, during, and after the cast period. The disused region, which is again represented by the blue dots, separated from the remainder of the somatomotor cortex, but it remained internally connected. And then the connection resumed to initial state when the cast was removed. Here we can see the percentage of pulses that occurred spontaneously inside of the brain region of interest. During the cast period, 66% of the pulses occurred spontaneously, and they increased significantly already in the first days after the cast placement, as we can see. Already after 12 hours, the disused regions of the somatomotor cortex and cerebellum functionally disconnected from the opposite hemisphere, and the same region become more connected to each other. Prior to casting, all participants showed strong homotopic functional connectivity. Casting led to a large reduction in functional connectivity between the two hemispheres and also between the disused upper extremity region of the cerebellum and its homotopic counterpart. And inside the subcircuit, the opposite happened. Large pulses propagated inside the subcircuit during the cast period. As already known from previous literature, patterns of coactivation are accumulated over many years, but now we see that alteration of functional connectivity can occur much faster because we saw the large pulses of spontaneous activity that propagated through the disused subcircuits as soon as 12 hours after placing the cast. This shows that the adult brain circuit self-organizes through spontaneous activity, and the recent behavior, in this case immobility of an arm, influences the functional connectivity. And we conclude that these spontaneous pulses act as protectors of the integrity of the disused subcircuit. They help maintain its internal functional connectivity. These findings are very important because they show that the recent behavior, in this case immobility of an arm, influences the functional connectivity. And this knowledge can improve studies that relate to patients that suffered from stroke or limb amputation, because now we know that some activity pulses that we can observe in these cases may come as a result of an inactive limb and not as a symptom of their disorder. For the future, further research is necessary to test the small differences between the observed functional connectivity during spontaneous activity and the activity that we could observe now in the disused pulse. Thank you.